All right, good morning, guys. Can you guys see my screen with my VS Code and SQL Draw? Let me just get a thumbs up from somebody. Awesome. All right, well, good morning. Today, we're going to go ahead and continue off from where we left off. The last thing that we covered was constraints and relationships. Today, we're going to build off of that and move to queries and joins. So we're going to go ahead and we're going to dive into the best practices for working with a new database and kind of familiarizing ourselves with it. When you start working with an unfamiliar database, you want to understand its structure, relationship, and its constraints, right? So we're going to go ahead and explore some strategies to help you work efficiently and avoid some common mistakes along the way. Let me just find it. It's right here. All right, so exploring your database structure. The first good practice will be utilizing your schema and your table descriptions. So many databases have a description for their schemas and their tables, and these descriptions can explain the purpose of each element, which can make a big difference as you get to know the database structure. A big help is really with your relationships as well. Unfortunately, unless you know about it, you don't know about it, right? So it's not a table that you can kind of just see out in the open. You know, when we're going through our constraints and our relationships and we're creating our database and we select it all from our tables, or just select the list of relationships that we had, you never really saw anything that looked something similar to a comment. It was just two different tables, one being the table itself, and then the sequence table that tracked the incrementation of the serial primary key, but we never saw anything like a description. And that's because Postgres kind of has it hidden, right? It has a separate table named page description, and the way to access it will be by using this command down here, where you essentially do select object description and you call the table that you're looking for using the reg class option here. And we'll talk more about that once we get into the queries and joins. All right, but utilizing the descriptions and your table and your schema, or essentially just the comments as well, to ensure you understand what the relationship between your tables are. Bad practice will be, the complete opposite, or where you just neglect any kind of documentation or the comments on your tables. So not doing that or paying attention to the relationship between your table can lead to confusion for you and your team. Do I have any questions on utilizing the schema and table descriptions? Okay. Next one we're going to talk about is going to be querying the database. All right, so a good practice is always starting with the select statement. It's a safe and easy way to explore your data, and you kind of saw an example of that from last week's class. The select asterisk from your table will retrieve all the columns from a table. Kind of think of like regex, right? Where the asterisk is. So selecting all from your table, you'll notice that we'll use select to start out most of our queries. And a bad practice will be not understanding or the data and modifying it. Not realizing the impact it can have on your database. So avoid jumping straight into updates or deletes for your table without understanding the impact and the relationship between your tables. So have any question on querying your database? All right, moving on. Analyzing the data relationships, right? So you guys have already seen how we create the relations between our tables, whether being a one-to-one, many-to-one, or a many-to-many connection. So whenever you are introduced to a brand new database and you're not familiar with the tables, it's always important to, for the most part, at least understand also the relations between your tables. So examining all the foreign keys, their relationships, whether they are a many-to-one, whether they're a one-to-one, identifying if it's being enforce, right? So I believe I was asked a question last week, like, what's the point of adding the foreign key if it'll still work if you just add like the ID from the table? Well, it's you know the concept of enforcing it and being able to actually see that relationship to understand how they work, right? So it's a little of a semantic meaning at the same time, but that's why we have the foreign key relationships and why we put that, right? So ignoring the foreign key constraints, right, can lead to inconsistencies in your data. So analyze the data relationships, and it's always good practice, and we're going to do that today too, is to draw out your table, right? To draw out your database, whether it's on pen and paper or using a tool like Draw SQL, where you can visualize your database, the fields that it has, the constraints, as well as the relationships that they share amongst each other. The next one, actually, before I move forward, do I have any questions on data relationships? Pretty straightforward. Awesome. All right, ensuring data integrity, right? Data integrity, you'll see this really play an impact once we start working with Django and talking to our database, but applying constraints for data quality. So that meaning, ensuring that if something is not supposed to be null, you have to not know, right? And you'll see that the null value, typically it relates to how data gets saved into your database. So ensuring that you have the proper constraints for your field. So if it's not null, putting no, not null, or if it is, putting no, ensuring you have the proper check to maintain that integrity. You don't want to have values that you don't want specifically, whether it's too low, too high, or does not match a certain input. So applying those constraints to ensure you have the quality of the data that you're looking for. And then last but not least will be monitoring your performance using the explain analyze. Um, we talked about indexes last week, being how to improve the performance when you have a specific field that you're trying to query and you know that you'll be querying often. We talked about being able to add an index to that to increase that performance. We didn't demonstrate how to do that yet. And that's kind of what you see here, the explain analyze, and we'll see that in action today as well. But using explain analyze, essentially an index for your query optimization, we see a preview here of how that is actually written. But by monitoring your performance, we can see explain analyze will give us how fast something is running, how long it's taking to run, and seeing if there's better ways of improving that by adding an index onto it. So we'll show you how explain analyze works and how to actually add the index on it. But neglecting the query performance, right? So not actually checking how efficiently something is running, depending on how much data you have. By neglecting it, you're essentially just wasting the ability to improve how optimal your database can run, right? So it's a tool, use it. Next, we're gonna go ahead and kind of put all these topics that we just talked into play. I'm currently within my queries folder, and within this folder, we have a directory named example, which holds data, and a file called car shop SQL. All right, I'm gonna go ahead and open up this car shop SQL. Let me zoom in a little bit for you guys. And as you can see, this is the creation of our database. We see here we have a table called department. We have another table called employees, followed by services, driver, car, plate, car service, and I believe that's it. All right, we have all these tables here with different types of fields as well as constraints. And we also see some relationships in play. All right. In this scenario, I was given this, and I have to familiarize myself with the database uh, before I can start writing some code. All right, so we're gonna go ahead and use what we talked about and put it in action. I have my Draw SQL tab open here. We're gonna go ahead and come here and add a new diagram, and I'm gonna call this car shop. Database type is gonna be a Postgres SQL, and we're gonna go ahead and create our diagram. All right, so I'm gonna go ahead and start us off with our first table. And then after I start us off, we'll take some volunteers and kind of walk through how to convert this into a table in Draw SQL, and how to navigate it. I feel like you guys have seen this. We worked a little bit with it, but we're still struggling a little bit of how to actually create this and put it into a visual representation. So we're gonna create this new table. We're going to change the name of this table to department. So we'll call it department. And this takes an ID. We'll add this in as integer. So it has an ID field, type int. It is a serial primary key. Automatically, when you create the table, the first field tends to already be an ID. So we see this, it's kind of already selected the primary key value. And by default, the items are nullable, right? I believe, I'm sorry, I will correct myself. It's not nullable, right? So by selecting it, we give it an option of being nullable. So by default, it is not nullable, right? So we just leave that blank. If we had other constraints, what we would do is we will add it within the comment section here. But it just takes an ID, serial primary key, and we'll leave it at that. The next item that we'll add within our department table will be the department name. And this is of type varchar. And it takes 50 characters. It is not null. So we'll leave it like that. And then it is unique. So unique. And we have no other constraints. Right. And that is my department table. Right. So who wants to walk me through the process of doing employees? Let's get a volunteer before I call somebody. All right, Gary, you look super excited. Help me out here.
Well, first off, isn't ID and department supposed to be serial
ID and department.
instead of int?
Oh, I didn't know they had a serial type. Thank you. Thanks,
Yeah.
Gary. I learn something new every day. That's pretty cool. I guess they did have a serial type. I was not aware of that. Good catch, which makes you even more perfect to start us off with the employee table.
Okay. All right. So, do we have the second table already up?
Correct. This is table 2.
Yep. That's going to be called employees. The ID is going to be serial. That's the primary key. Next off, we'll create another column called salary. It's going to be a decimal, 7,2. Next column is going to be first name.
What do you forget before we move on? What do you forget on the salary? So we got the salary. We got it to be a decimal type. 7 characters with a decimal at position 2. We also have the not null.
Yep.
We talked about that being a default, right? But one thing that we did overlook was the check, right? A constraint. Um, so I mentioned earlier, we can kind of click these three dots and we have the little
Oh,
section
I
here,
see.
right? And this is how we will add the constraint here within Draw SQL. So it would be check for salary greater than 0. And then we should see here on the salary field, there is a kind of like a chat box that we can click and it shows us a comment where our check for this field is located at. Sorry, I didn't mean to cut you off, Gary. You're doing good.
Oh, you good. The
Next,
more you know. First name, we got varchar. And what do you want to put? Yeah, just 255 or it says 50, so you can just do 50.
correct, right?
That's also going to be not null.
Yep, not no. Default is not no.
Yep. And then we don't have any checks for that, so we can go off to the next column called middle init, and that's just going to be char1. And it looks like it is nullable. So the next column is now going to be last name, varchar 50, not null. Next column is going to be department ID, which is going to be an integer.
Oh,
Uh,
and type.
just checking real quick. Is department ID going to connect it to a table called,
That
yeah,
is a very good question. Yeah. So we finally get to our first relationship here, right? So employees, it has a field called department ID, right, of type integer. And then following that field, we see the foreign key, right? We see that we currently have a foreign key. This foreign key is the department ID. This department ID foreign key has a reference to the department table, which is located up here. And in that department table, the reference is the ID, right? So this department ID is referencing the ID in the department table, right? Does that make sense? Now, what type of relationship is this, Gary?
it looks like it's just going to be a one-to-one. Is that correct?
What enforces the one-to-one in this relationship?
The foreign key.
Not exactly. So the foreign key does create the relationship, right? But if we recall, when talking about the many to one and the one to one, is what enforces that relationship is uh, the uniqueness of the foreign key itself, right? So what this tells me
Oh,
here is that this department ID that it currently has saved into employees is not unique, right? That means I can create multiple different employees, right? And they can all have the exact same department ID, therefore having multiple employees that can belong to one single department. If this was a one-to-one relationship, we would add the unique field within the department ID. So whenever a new employee is created and you add a department that it belongs to, it can only have, a specific unique department. If we try to make a second employee and give it the exact same department that employee one had, you're going to have an issue, right? And that issue is going to come from the fact that that department ID is supposed to be unique and you're trying to repeat that ID in a different employee, right? So as of right now, what this table is telling me, because the department ID is not unique, that means that there is multiple employees that can have the exact same department, therefore making this a many-to-one relationship, right? So we're going to grab the department ID, and it has, as we see here on line 18, it has a reference to the department table. on the ID itself. And the type of relationship it has is a many to one, right? Many employees to one department. Sound good? Yes,
Yep.
Jacob.
Yeah, I think a couple people were asking in the chat, and it kind of made me curious. Does department ID have to be nullable? Or not null, I mean, since it's uh yeah, I was just wondering that too. Some people were asking that in the chat if department ID has to be not null.
That's a good question. Well, I would say if I was framing this, I wanted to make sure that every employee has a department before adding him here, and I would. But maybe this employee doesn't have a department yet, right? Maybe he hasn't been assigned yet.
Okay.
So I mean, it depends on your the intention of what you're trying to create this database. Does that make
Okay.
sense?
Yeah, that makes sense. Thank you.
But yes, I believe Juan.
I'm sorry, did you want to finish your thought first?
No, it's fine.
All right. I was gonna ask, since department ID, it's getting, or in the employees tab is getting the foreign key from the department's table, which is a serial primary key. Isn't that where that relationship would be drawn and making it not null because it has to get it from over there, or no?
That is a good question. I'm actually gonna put a bookmark on that, and I will let you know. I don't know off the top of my head, but thank you for that question. Let me write it down somewhere. Does anyone besides Juan have any other question? Okay. Thank you, Juan, for that question. That was actually pretty good. I'll look into it because I don't know off the top of my head. Moving forward, if nobody else has any more questions besides the one that Juan asked, what did you forget, Gary? So we have the department ID. What's left?
The check.
The check, right? The check goes on what?
It goes in the comments.
The comments. What do you mean the comments?
Well, so we're sorry. So
Oh,
for middle
my
in
bad.
it, yep. So for middle
You're
in it, we're
absolutely right.
gonna go into the we're gonna comment and
Correct.
we're going to check if middle in it is null or the length of middle in it is equal to 1.
Or length middle init equal to 1. I think Postgres will do 1. Yeah. So checking whether middle initial is equal null or the length of middle init is equal to 1. Good stuff. Sorry, I don't know where my head went when you said comment. I was like, comment. Like, what are you talking about? Thank you. Okay, good stuff. Good stuff, Gary. So we got department. We have our employees table with both constraints, and we have the relationship between department ID and our department.
Quick question. In that check where you check middle initial is null, you put equal null instead of is null. Is that how we're supposed to do it?
So we're checking, is middle init null, or does the length of middle init equals 1? So this is just like saying it, middle init equals null or length middle init equals 1. Does that make sense?
Yes, I'm just making sure that the
So,
equal and the is the same thing.
we'll see once we start querying stuff. Whenever we try to check if something is equal to itself, you would think, right? Whenever we work with Python and JavaScript, we like to use like the double equal signs. It's gonna be a little bit different with Postgres. right? When we try to see if something is equal to itself, or like if we try to say, hey, does name equal John, right? We won't use two equal signs. We will be using one, which is why I just use one right now, just for that. Does that make sense? Awesome. Yeah, I don't know why it's different. They gotta kind of get a meeting together and figure out their lives. But moving forward. All right, so we got employees. Let's go ahead and get a volunteer for services.
Before we leave employees, you can make a comment on the entire table. And I feel like for the employees table, adding the whatever you want to call the foreign key, department ID, what is that? What is the actual word that we use?
The relationship?
The relationship, yeah. Wouldn't that be appropriate there?
We could, but we are taking advantage of the fact that we can use these connections here.
That makes sense.
That is a good recommendation. Thank you. But we do have this other option. But yes.
I'll move on to services then. So you create your ID. It's a serial.
So this table is services. So I'm
Yep.
a little behind. We have our ID, just like you mentioned. It is of type serial and a
Yes.
primary key.
And then your next column will be name of service. And it'll be varchar 100. And that is unique. So you'd go into the, there we go. And then not null. And then your last one is price. That is a decimal with the values of 7 and 2. And then you can add a comment of check price is greater than or equal to 0.
Good stuff. Good stuff. All right. Thank you, Owen. We see here services does not have any kind of relationship yet. It is independent. We'll go ahead and move that down here since it likes to be an individual. All right. So we got services. Next, we have driver. Let's get a separate volunteer for driver. Jacob, I see your hand.
Yeah, I just wanted to ask real quick about Cascade. Do we have to implement that at all for driver? I don't remember what Cascade does exactly.
That's a great question. So Cascade, so what happens, right? And the reason why we use Cascade is when we start creating these relationships, they become dependent on themselves, right? Think of it like, oh, if I don't have you, I can't continue living on my own, kind of thing, right? You know, these tables are very dramatic, so they need to know what to do if their partner that they have the relationship with is no longer present. So if we have something like driver and car, where they have a relationship, together, like, hey, I'm the driver, this is my car, I can drive it, and the car itself is like, hey, I'm a car, I have someone that can drive it. Right? They have that relationship amongst each other. You can reference the car of someone, or who the driver of the car is. Well, what happens if we remove one of those out of the equation? Well, because we have it in our code, right, that, hey, there is a relationship here. There's a foreign key, right? Let's look at, for example, our car and our driver. Within this car table, there is a foreign key. This car is saying, hey, I have a relationship with this driver, right? I have his ID within my table, right? And what happens if I try to delete driver, but there's still a car that has that relationship? Well, it won't know what to do with it, right? We're gonna try, if we try to drop the table from driver, it'll say, hey, like, you can't do that. Driver is currently being depended on by the car, right? Because the car is currently holding IDs from driver. So what am I supposed to do with car if you just remove the driver out of the equation, right? And that's when Cascade comes into play. Cascade pretty much tells your code that, hey, I'm trying to drop this table. Cascade says, okay, well, by having Cascade in here, you're telling me that if you have some kind of relationship, it's okay, I will drop you, and there won't be an issue, right? So cascade is just kind of just removing dependency amongst each other. Does that make sense?
Yeah, thank you so much. I appreciate it.
No problem. Do I have any other questions before I move on, guys? Awesome. So, Jacob, since you were the last one talking, do you mind helping us out with the driver one?
Sure. Yeah, you'll have to create a new table and name it driver.
Create a new table. We'll call this driver.
Okay. You'll have to do ID and then have it set as serial, and then that's going to be a primary key. And yeah, never mind. I can ignore the null thing, I think so. And then we're gonna do make, and that's gonna be varchar 50. Are we sorry, we're in driver, my bad.
It's okay.
Yeah, so ID name, it's gonna be name for driver, and then varchar 100. And it's not null. And then we can move on to phone. That's going to be varchar 15. And then that's going to be nullable. Yeah, and that should be good for that. And then we can add email, varchar 100, and make that nullable. And then age is going to be int. And then we're going to add the comment for the constraint that age has to be greater than or equal to 0.
Check age greater or equal to 0.
Yep.
All right, good stuff. So we have our driver, our services, and then the connection between department and employees. So far, so good, guys. No relationship here, so we can go ahead and move forward. The next table will be card. Can I get a different volunteer for card?
I'll take it.
Let's get it.
So we're gonna make a new table. We're gonna name it car.
Yep.
And then for our ID, it's gonna be serial, and it's already a primary key.
Correct.
Then we're gonna make a new column of make varchar 50, and it's already not null. And then we're gonna go ahead and make model, and then that one's gonna be varchar 50 as well. And another one we're gonna make year, and then int. And within that check, we're gonna make sure it's commented year is greater than or equal to 1900.
At the check, year greater than or equal to 1900. Correct.
Yep. And then another column, and this one's going to be color varchar 20. And then another one, we're going to make driver and integer. And then this one's going to have, because this was going to have a relationship with the driver, and it's referencing towards the driver ID. Let's see,
Correct.
so we could have many. So we're going to make the driver unique, because there can only be one. Or no, we don't need to.
What kind of
Driver and
relationship?
car. It would just be a 1-to-1, wouldn't it? Because it's just one car to one driver.
Well, according to this SQL file, remember, right? The scenario is we just got this job, we got handed a SQL file, and we're trying to familiarize ourselves with this database. So we are creating the SQL table here or schema within Draw SQL. So by looking at this, what does this tell me that the relationship is? I can't assume it's a 1-to-1, right? Because my concept would be like, yeah, I have one card to one person. you can't assume that. You have to read whatever the the SQL file shows you, and then obviously if you have these questions, then you would gather all these questions and ask them to whoever your leader is. And you're like, hey, I have some questions. I was going to the database and I saw that within the card table, it has a this type of relationship with this table. Why do we have this relationship? And that's when they can explain to you the reason behind why it's set up. But looking at this scenario, what kind of relationship would you say driver and car have? We see here that car has a foreign key within this table, right? It's the driver ID, right? It says, hey, here's the foreign key. The foreign key is whatever driver is. This is going to reference the driver table. And in this table, I want you to reference the ID itself, right? So whatever driver there is an ID for that from that driver inside this car. Right. And thinking back to the relations when it comes to many-to-one and one-to-one, what enforces the one-to-one relationship within these tables? Right, because they look fairly similar, but there's one specific thing that enforces that one-to-one connection.
Them being unique.
The unique, right? If there was unique here on line 55, that means that each car can only have one driver, therefore making it one-to-one. But because its driver foreign key is not unique, that means I can have multiple cars that share the same driver ID within that table or that field, and I won't get an issue. Therefore, making it multiple cars to one driver, right?
Okay.
So this car shares a many-to-one relationship with a driver and is referencing the driver ID. There we go.
Okay, that makes sense.
Okay, any more questions, guys? Does anyone have a question in regards to the many-to-one or the one-to-one relationship that car and driver have? Yes, Gary.
Are you supposed to declare anything as unique for this?
We do not declare anything. This file was handed to us. What I am doing is drawing my tables out and figuring out what these relationships are. Right? Driver, as I see here in this file, does not say unique. I'm not gonna go in here and start manipulating stuff. I didn't create this database, right? Like, I'm just trying to familiarize myself with the relationships. So it is not unique. Therefore, that tells me this is a many-to-one relationship. Make sense, Gary? Awesome. Anybody else? All right.
Were we done with the car table? Because did we mark it as a foreign key for driver?
Correct. This is the car right here.
Yeah.
It has the driver ID here,
Mhm.
and it has that connection, right? The many
Okay.
to one connection with driver.
Gotcha.
All right, we have 2 left. Let me get a volunteer for plate, please.
I'll do plate. But real quick, I got a quick question. So that
Yes.
many-to-one relationship that you draw out symbolizes the foreign key. That's what you just basically said?
Correct. Pretty sure this doesn't have one. I can check. Unique key, index, primary key. Nope. There's no foreign key option here. If you would like, you can come here into the comment and say like foreign key, right? Foreign key, and tell it what the foreign key is if you want to specify. But by looking just at the table without checking any kind of comments and seeing the connection right here between the driver and then ID, I know that this is already a connection. Right, this tells me this is a many-to-one relationship. The foreign key is in car. How do I know that? Well, because I see driver ID here, and normally we would want to make sure the naming convention for the IDs in each table is specific to that table. So it doesn't have it in this example, right? But you would like to do something like driver ID, right? This is telling me, hey, there's a driver ID, and this driver ID is currently being connected to car. So that means driver ID is in the car table. And that's what driver is, right? It is that driver ID, is the type integer. Like I know that these are connected, right? Typically when you have a many-to-one relationship, the foreign key is placed onto the table that is many, right? So driver would be 1, and the car is many, therefore the foreign key is placed into the car table. Right, so whatever is the many part, that's the one that gets the foreign key. Right, that's how that works. So I know without checking any kind of comments that car has a foreign key. Right, it has a many-to-one relationship shared with driver, with that foreign key being the driver ID type integer. Does that make sense?
Yes.
Awesome. All right, let's go ahead and move forward. So I believe it was you, James, talking through the plates.
Yes. So you got your ID. It's going to be serial,
Serial.
and that automatically marks it as the primary key, correct?
Correct. It's already set as primary key, and it's not null.
Okay. And then so the next column is going to be plate underscore number. That's going to be a varchar of 10. We're going to mark it as unique, and it's going to be not null.
Yep.
And then your last column is going to be car ID, car underscore ID. It's going to be int.
All right.
And it's going to be a many-to-one relationship to cars, the table car ID.
Now explain to me why it's a many-to-one relationship.
Because car ID is not unique.
Perfect. Thank you. That's absolutely correct. Right? Because the car ID is not unique. That means that I can have multiple plates, right, with different with the same car ID, right? Because it's not unique, that means I can repeat it into different other tables, right? So that means car ID has a many-to-one relationship with plates. All right, so car ID right here, it's multiple plates to one car. No, multiple car IDs to one plate. Okay. So we see the car being the foreign key within plate. It shows it's a many-to-one relationship with car. Do I have any questions about plate and car before I move forward? I don't see any questions and no
I
hands
do.
are. Yes.
So the database doesn't care if, so with your many-to-one relationships, it doesn't care if car ID has the same exact ID multiple times. All it cares about is that many-to-one relationship, and the car ID can have it can be the same car ID for 100 cars. I mean, not cars or plates.
Correct.
100 plates with the same car ID.
Correct. That's the many-to-one relationship. We have many plates to one car. Once again, I don't know why this scenario is built this way, why this car shop has it this way. I'm not very car savvy, as a matter of fact. So I don't know if you can have multiple plates. But in this scenario, multiple plates can belong to one car. So that's why car ID is not unique. so we can repeat them with other instances of plates. Does that make sense?
Yes, gotcha. Thanks.
Awesome, no problem. All right, let's get my last volunteer for car service. Demi, you seem very excited. Help me out, please, through car service.
Create another table.
Create our last table.
Yep.
Call it car
Car
service.
service. Then one of the columns, yeah, ID, and then change it to serial.
Serial.
Then it defaults to primary, so we're good on that. Then another column, service ID, and then the type is int. Null. Yeah, add another column. And then car ID. And that'll be an int as well. And then you'll make the connection for the service ID to services ID, which is on the left, yep, on the left side above driver. And then the next connection, oh, well, it's a many to one. And
Many to one.
then,
Right.
yep, and then the car ID will just reference the car ID, or yeah, the ID on the car table with the many to one.
How can I format these to make them look better? Okay. Awesome work, Demi. Jacob, I see your hand raised. Yes.
I don't remember if we did it, but do service ID and car ID have to be nullable?
Service ID and car ID. This is telling me that they are nullable by not having not null, but Juan raised a great question. He asked, well, by making a foreign key and referencing it to the service ID, which is a serial primary key, that should make it not nullable, correct? And I told him I don't know off the top of my head, so I'll do
Oh,
a
okay.
research a bit. But
all right,
you know,
that's what you guys
I
are talking
would
about. Okay.
assume, using my best judgment, I would assume that is correct. It should make it not nullable by the fact that it has that relationship. It's gonna ask you for the relationship, right?
Gotcha.
But the exact answer, I'm like 90% correct. I just I need to actually see it for me to believe it completely.
Right. Okay.
Good stuff. Right. So this last one, guys, car service. This was our last example, and this was a many to many relationship, right? The car service was that third table that we discussed that essentially makes the connection between two different tables. Before, with the many to one, we didn't have to have a third table. It could be as simple as having those two tables. You put a foreign key from one into the other. But it gets difficult when you try to have many to many relationships because they can't be unique since they're supposed to be able to have multiple instances of each other, right? So if I make a plate that's unique, right, or a card that's unique, and I'm trying to connect to a plate, then when I add the foreign key into that plate and make it unique, it makes it a one-to-one, right? So it has to stay not unique. And that's what happens when I try to do a many-to-many relationship, is when I start trying to add foreign keys on both sides, it won't work because of the uniqueness, right? And that's where that third table came into play. What happens here is that for a car, right, a car is able to have multiple car services, right? But each car service can only have one car and one service being conducted. right? Each service can belong to multiple different car services. Does that make sense? That's how these two come together, right? And notice that the way that we link them is by adding the IDs of both car and service within car service. That's all we need. We just need those. We can use those IDs to reference both tables. We don't need no fancy other fields in here. That table is only there to be able to make that connection between two different ones. It's like our little mediator, right? A little connector. That's all that table is doing. Do I have any questions? All right. If I have no other questions, we're gonna go on a 10-minute break. Mainly because I have to do something real quick. And then we'll come back and finish the last part of today's lesson. So time is 9:53. Let's come back at 10:03. All right, welcome back, guys. Can you guys see my VS Code? We should be looking at the SQL file. All right. So we just finished going over how to familiarize ourselves with our database, right? We took a carshop.sql file that we are unfamiliar with, we had not seen before, and we essentially dissected it from top to bottom, looked at every single field, was able to draw our tables within Draw SQL, and look at the relationships and how our tables interact with each other. Now, we're going to use this exact same Draw SQL file. And we're going to go ahead and load it up into our database and see how it looks like. You're also going to notice that within our directory, we have a data folder, right? If you open up this data folder, you're going to see a bunch of different CSV files. And we're going to go ahead and go through every single one of them. Notice the naming of these files are very similar to the table names. And you might have already caught on to the copy employees from, and it tells you where it's copying the CSV from, right? So besides the fact that it's creating tables here, it's also adding the data into our tables. We can go into car service. We see here car service, which was a table that was used for the many-to-many connection. Has exactly that, just the IDs of service and car. We have car, we have different the different fields: ID, make, model, year, color, and then driver. Remembering the car that it had a foreign key, that foreign key was the ID from driver being present in there. We have our departments: mechanical, electrical, and body shop. Our drivers, fairly simple. Nothing complex here. The email, their ages. We have the employees, our plates, and the actual services that we provide at this car shop. So coming down here, someone remind me, how do I run my SQL file to add it into my database and to add it into my database, right? There's two methods that we discussed. Who can tell me one of them? Yes, Owen.
You would first go into your database through PSQL.
Correct. So let me go ahead and connect to my database. I'm going to go ahead and use /L. And I can see I have a bunch of database that I've used throughout my time at Platoon and teaching. I do have a database here called CarShopDB, which I'm not going to use right off the bat because I already worked with it. So I'm going to go ahead and drop this database and then recreate it. So we're going to do drop database. And I'm going to drop the car shop database. We see here that it was dropped successfully. And then I can create database and recreate it again. All right, so from where you left off, Owen, we do want to, we can connect into our database, or we can actually do it from the command line, right? I'm assuming you're going with the one that's connected.
I would,
right?
yeah, /C and then your database name.
Okay. We're connected into our database.
And then you can run, I would probably open car shop SQL just to make sure that's the file you want to use. Yep, that's the correct one. And then you can do /i carshop.sql as long as you're in the correct directory, which you are.
I believe I am. If not, we will see. Awesome.
Sick.
Right. So awesome. Good job, Owen. The other method, guys, for the sake of reminding you guys, is by using PSQL, right, from my terminal, right, from my working directory wherever it was at. I would run PSQL, the name of the database, a less than sign, right, the little arrow, and then I would call the name of the file I'm trying to dump into it, right? Gary, I saw your hand raised and go back down.
Yeah, because I thought, never mind, because you just went through it.
Yeah, it would look something like this, where I'll say PSQL. I want to dump into the car shop database. And inside here, I want to dump car shop.sql, right? That's how it would look like if I did it from my terminal. All right, cool stuff. I'm glad you guys remember it. All right, so we see here, everything went perfectly. I'm not gonna go line by line every single one of these. We see that we tried to drop the tables if they existed, and then we created them and we copied all the data from the corresponding CSV files. Right. So now that we are in our car shop database, I can do /D, and it's going to give me all the relations within this database. We see all the tables. We have car service, department, and every single one of these tables has their corresponding sequence table. Someone remind me what the sequence table does and what it's worth.
Does it automatically like increment like the integer values of the car IDs? So like when you add a new car or whatever with an it automatically assigns it to whatever it was in the frequency. So like the car one, and then if you insert another car after that, it automatically assigns it with an ID of 2. Is that correct?
Spot on. It keeps track of the last value used for our serial primary key, right? It uses that last value, so it knows what to increment the next number. You might notice that within the SQL file, we don't have us manipulating that sequence, and we can see what it looks like. We can select all from car. We have the all the data from our car table. The last value added within our ID was 10. But if we do select all from car ID sequence, we see the last value is 1, right? So that wasn't added to a SQL file, but if we intended to add more data afterwards, we probably want to add it to our SQL file that we wanted to change that last value once we dump that data in there, right? Once we copy from it. This is not part of the lesson for today, so it wasn't added. I just wanted to make sure I showed you guys that so you guys are aware of it once you guys are working with stuff like this. Now, so moving on, we're gonna go talk about adding comments into our tables. So we created our tables, we established the relationships. You see that we have many to many relationships and many to one relationships. But when I select all from cart, I don't see that, right? I can see that there is a driver column, and this column has the IDs from driver, but there's nothing here that's telling me there's a relationship between them. Sorry, a second. I was getting a phone call. All right, and how do we do that? Well, if you recall earlier today when we were talking at the beginning of the class, we talked about comments, right? And our comments is what's going to allow us as developers to add a comment here to let other developers know the relationships that these tables share. We can do that from our database, and we're going to set up with our SQL. All right. So we navigate to our SQL file, and we're gonna add a comment line right after the table that holds the relationship. So we have, where's my card table? We have this card table, and we see that this card table does have a foreign key with driver. And what we'll do is, after the table, we will say comment on table, and the table that I want to comment on is going to be car is, and then I'm going to open some parentheses here, and I'm going to say car has a many to one relationship with driver. Right, and that's going to add a comment to this table. But when we come back, I'm going to have to rerun this again. PSQL car shop DB into because I'm not within the directory. Okay. Drop table if exists. I'm getting an error here. Key ID already exists on plate. If we add that. Okay. There we go. I was getting an issue here on the comment, right? It wasn't really correct because I didn't add the semicolon. But we add the comment after our card. And then what I did is I reran that SQL file. I opened up a different terminal so I can do it, so I can keep my database open, but I can still rerun the SQL file without having to close it. And we come down to the inputs of what happened when I ran the SQL file. Everything ran as normal, but notice that at a certain part, we see here that a comment was created. Right now, if we go back to our database and we select all from cart, we still don't see that comment. And going back to what we discussed earlier this morning, Postgres has the comment, but it doesn't easily give it to you, right? It's one of those that if you don't know, you don't know. And we discussed that there is a specific command to be able to grab that comment. And that command is as follows. Within our database, we're going to do select. I want to select the object description. Open and close parentheses. Within here, I'm going to add the table name. The table is going to be car. That's where my description is located at. And then we're going to use this function that's in Postgres called reg class. Reg class stands for registered classes. In other words, the tables. Now, if you ask me how this works, I'll be transparent with you. I don't know the exact under the hood way of how this works. Right, just know that by doing the object description, we're able to grab the comments of whatever table we pass in within here. And then when we run this, we see here the comment that we created is given to us. Car has a many-to-one relationship with driver. Do I have any questions about comments on tables and how to grab them? Yes, Jacob.
So just to reiterate one more time, just to kind of make sure I have it down. So like when say like car has the many end of the relationship because it has that foreign key that it references to driver. So that's what indicates that that's where the many relationship is, correct?
Correct.
Okay. All right. And then, okay. Yeah, I got you. Cool.
If you wanted to, you could add a comment onto the driver one as well.
Yeah.
Right. You could add it, hey, driver has a many-to-one relationship with car. The foreign key is within the car table. Whatever helps you guys as developers understand what is going on within your table, so you could do that.
Yeah, because that was always the trouble when I've learned databases before, was just understanding how to determine many to one based on like foreign keys and stuff like that. So yeah, all right, cool. Thank you.
Yeah, no problem. I know it's not the easiest, just having data there, like, oh, where is these relationships, right? Well, we could do that by the comments.
Okay. All right, cool.
Anybody else? I'm sorry, I'm gonna have the chat open. Let me open it up. Any questions besides Jacob's? Yes, Gary.
I was just wondering if we know what the reg class is like short for, or like what that even is.
Reg class stands for registered classes. That is referring to your tables, right? So it's saying, hey, car from my registered classes. What is registered classes? Your tables. All right, so car from all my tables. So grab this car for the tables that I have. Okay, I see a nod. Good to go. All right. So we were able to see the comment by running the select object description. Now that takes care of comments. We're gonna go ahead and move forward with to this class, which is gonna be query and joins. All right. So I'm gonna start off with querying, but we're gonna take a small sidetrack to talk about indexes. So we have our database, and when it comes to querying, we talked about best practices, and that being starting our queries with select. And you guys have already seen me use some simple one, which is select all from car. But as you guys might have guessed, especially if you've seen SQL before, there is different ways of querying. And we're gonna start talking about those today. So right now we're able to grab everything from car. But what if I want to grab a specific year within this table, right? We see the example here when in our README. If we want to grab everything from a car where the year is greater than 2019, we would start this query by using select all from car. And what this says, right, that select all from, it's saying what fields to grab, right? Right now, by using the asterisk saying all, I'm going to grab every single field that this table has. That's going from ID all the way to driver, right? Select all from card, where, right? And where is kind of like an if statement, right? Where we're checking if a condition is met, right? And the condition that I'm trying to check here is whether year is greater or equal to 2019. And when I run this, I see here that I get back all the cars where the year is 2019 or greater, right? It filtered out 2017, 2018, and it only gave me back 2019 and above. Notice that we also got every single field here because we did this select all from car where year is greater than 2019. So we talked about comments. One thing that we mentioned before we get to see is indexes, right? And why they matter. Well, we run this, but this doesn't really show us how accurate or how optimal this query is. And what we can do is use an explain clause, right? We can say explain, select all from car, where year is greater or equal to 2019. And we will run this. And what we see here is that once again, we are querying that car table, but this time it's not giving us the table, it's explaining to us how the table is running. We see here a sequence scan, and what that's telling me is that it's iterating through the table. It has rows and width, and it told me what it filtered out. right? But this doesn't really give me the performance. It tells me how the filter work, how the query works. But if I wanted to see performance, I would use explain analyze, right? And we saw that in the readme this morning. Explain analyze, and that'll give me a lot more information than what explain did. When I run it this time, we don't just get what we got initially, which was a sequence scan. This time we get the runtime. We see the actual time it took to run all this, right? The rows and the loops, right? So this time right here is referring to how long it took to run that filter. We see that it removed 3 columns from that filter, right? That was the where is it at? The 2017 and then the 2018. So it removed 3 from my table, right? It filtered those out. And then we see planning time and execution time. It took 0.047 milliseconds to read my command and plan how it's going to work its function. And then to actually execute that and go to my database and grab all the information, it took 0.023 milliseconds. All right. And this is how we can see the performance of our queries. So this shows me the actual time it took to run. The rows it sent back. It tells me the filter, right, and what it removed. Now, we also see we have stuff like rows and width. And they kind of differ, right? Rows and width. What exactly is this? Because there's not 80 rows in my table. And essentially, the way that PostgreSQL works, it has a query planner, right? And it makes an estimate, and they estimated that it might find 80 rows that could match my filter. And this estimate is based on statistics that PostgreSQL maintains about data distribution, which can sometimes differ from the actual values. In this case, only 7 rows match the filter, right? Which is why you see rows 80 here and rows 7 here, right? This is what I estimated. Obviously, that wasn't accurate. It only found 7. The width is referring to how big this data is in bytes, right? So all these different fields, when we set the different types, whether it was varchar, whether it was int, big int, whatever it may be, right? Every single one of these fields has a specific amount of storage that it takes, right? I showed you a little bit of that, I believe last week. Small difference where like int, big int can go from int being 2 bytes, big int being 4 bytes. But in the grand scheme of things, when you have thousands of data, right, it can accumulate. So that's what the width is doing. It's essentially grabbing you how big this is in storage size. Now, moving forward, we see here the planning time and the execution time. Well, this is going to bring us to the next part, which is going to be indexing. Right, indexes, if you guys recall, is a way of optimizing our queries for data that we might use frequently. If I find myself constantly querying for the year of the cars, that might be somewhere where I want to focus all performance in. So I ensure that runs as fast as it can, so I can optimize my performance, right? Well, the way that works is we're gonna go ahead and go back to our SQL file. And what I'm going to do is add the index. I believe if I'm doing this correctly, it'll be right after the table where I can say create index. And then the index, I can call it whatever I want. I can say index car on car. And then what field do I want to do it on? Well, let's say it's going to be the year one. So we'll say index car year on the car table, the year field. Right? Now, when I come back down here, I rerun this. We're gonna see here. I don't know if it makes a difference. Okay. We see here we got two different inputs before the index was added and after the index was added. Right? On the was 0.009 milliseconds. This time it actually took a little bit longer, and I'll explain why. All right, we can compare the planning time and the execution time. It took longer to plan this query compared to the first time. Right? And that's because I added an index, so I had to take that into consideration. And the execution time also took longer, but I'll explain why. Right now, because we are only working with like 10 columns, it might not be worth the squeeze, right? So you don't actually see the benefit of using an index right now because actually, such a small amount of data. Adding the index won't really make a difference. Where index really shines is when you have a lot of data in your database. If you have like 500,000 different entries, that's where you will see the execution time start to outperform the execution time before the index was added. All right. So although this data right here, this result is a little misleading for our example, because I don't have 500,000, 500,000 entries. Just know that index will improve your performance. We see the effect happening here. It's just not the exact effect we're looking for due to the amount of data that we have. Do I have any question on indexes? Pretty straightforward. Awesome. All right. So now we can really get into the queries and joins. So that took care of indexes. We took care of comments. Next will be the actual queries. All right.
I have a question before you move on.
Yes, Owen.
So similarly to when you add serial to ID, does create index kind of create a new, I guess, table for tracking what those IDs are? And then in this case, it's an index instead. So like if you \L on CarShop DB right now, is that going to show? No, it does not. Okay.
It does not. When it comes to indexes, I want you to think of it as like a flag, right? It's kind of like, like a little flag, little identifier on a specific field type, right? So whenever it runs a query, it plans that query, it grabs the information, it's going to check the fields that you're looking for, it's going to get to year, and it's going to see the flag, which is index. Like, oh, what the heck? Like year has a index on it. It has a flag. Well, that means that my developer wants me to focus all my manpower, all my energy into ensuring that I get him the query with all the years as fast as possible compared to everything else. All right, so it'll improve their performance for that field. Does that make sense?
Yeah. So is this kind of getting into like your O of N and O of N log type performance, or is it just making it more efficient without that in consideration? Because kind of like how we use hash maps to make something pop potentially big O of 1 instead of O of N. Is it kind of doing something like that?
I see what you're saying.
Yeah.
comparing it to time complexity, if we were like thinking about steps, the steps don't change, right? So technically, if we were thinking like time complexity and using that as a reference, time complexity stay the same, but AI is gonna still work faster, right?
Gotcha.
Right. So now we're actually referencing like actual time. How long will it take? It will actually take time-wise a lot, less for it to create within the index. Right. It still has to go through all the steps. It's just like the hardware is just focusing on this one thing to make it run faster. Kind of like, I know a lot of you guys don't play video games, right? But for you guys who have like gaming laptops, I'm not complete tech savvy, but your gaming laptops have like special hardware that are supposed to improve the performance of your games, right? Improves your frame rates, right? The graphics. It focuses all its energy and power onto running your game as efficient as possible, right? Whereas regular laptops, it shares its performance with different stuff that you might have in the background, right? For those of you guys that might have like NVIDIA, installed onto your gaming computer. If you guys use NVIDIA, you can there's settings that you can have where it like pauses everything in the background, so it doesn't focus on other stuff while your game is running. It'll like pause everything else, say, hey, I'm gonna give all my attention only to your game to make sure you get the best experience possible. So essentially it's doing that, right? It's prioritizing your query over anything else that might be happening. Does that make sense? Gary, I see that you understand the reference. Does that make sense, Owen?
Yeah, it does. Thank you.
Tristan might understand this too. All right, right on. Okay, so moving on, go straight into our queries and our joins and strictly that. So we talked about selecting all from car. We're going to introduce the count. Let's go ahead. Let me open up this README, just ensure that we stay on topic. Let me format this a little bit. Let's close this up. It's all right. I got my own notes. If you guys want to follow along with the README, you guys can. So we have our car, right? We talked about doing select all from car, and that returned to us the entirety of the car table with every single field. We talked about using the where clause. We said select all from car where year is greater than or equal to 2019. That was able to filter out by year. We can also do something using the count operator. We can say select count all from car. And what the count operator does is that it gets every entry from car and it counts it, and it returns to you the count of how many entries are within your car table. All right, so we're able to use different types of operators, which we'll see within today's lesson. All right, the count operator will count every entry within your car table. We can also do a little bit more specific, where we can say select count. We're going to count everything from car. And now we can add our where clause, where color is equal to red. And unlike before, where we just said, hey, I want you to count everything that's in car, now we're just specifying what we want to count. And we only want to count everything where color is equal to red. Notice that this does matter, right? The way I had this set up is looking for a color that has this in its field, right? Red. And it counted to. When we go back to the table, it has everything we see here. Ford with ID 1 has red, and Hyundai with ID 9 has red. Therefore, it returned 2 to me. Any questions on count before I move forward? All right. So that takes care of count. The next one we're going to talk about is sum. Being able to use math within our queries. We have a price CSV with the, no, not price. I believe it's services. If we go to services, we see here that we have ID, name of service, and price. Well, what if I wanted to get the total sum of what getting the full package within this car shop? We're gonna do select sum. I want to grab the sum of price, put everything within price. And where is it at? It's in my services table. And this returns to me a column named sum with the actual sum of everything that belongs within the price field. Now, we got the sum, but we can also do something like average, right? Average. Well, let's go to our employees. And in our employees table, we have a column named salary. And I want to grab whatever the average of salary my employees make. I can say select. I will use the average operator. I want to select the average of salary from employees. And this returns to me the average that my employees make within my company. Now, you might be asking yourself, well, Roger, why is there so many zeros? When I created my, this table, I had decimal with the first argument being 7, second argument being 2. I believe that's what it is. Let's just double check. Let me go into our employees table. We see here salary is of type decimal. It's supposed to have 7 numbers, and the decimal is supposed to be at the second place from the right. But that's not what's being returned to me. Well, when we create the table is set so we have a way of how we take in information, right? Whenever we add information into our database, these constraints is how we take in the information. But when we query it, Postgres does something different. It's trying to be as accurate as possible with its data. Now, if that's not what you're looking for, you could be a little bit more specific and grab exactly what you initially intended it to be by using a round operator, right? And the way that's going to work is by wrapping the average salary within my round operator. I can say round, open and close parentheses. And within these parentheses, I'll do the exact same thing I did earlier where I say average, open and close parentheses again. Inside average, I will add salary. And what this is going to do is going to grab the average of whatever salary is. And then I'm going to round my result from that. And it's going to take a second argument. That second argument is going to be to how far I want to round it to. I want to round it to 2. And then I'm going to say from employees again, because this is where the information is coming from. And we see here now that we get exactly how our data was added into it. It rounds it to R2. Now, this might not be always what you want to do if you want to, shoot for accuracy. So it's not the best practice. It's honestly what you're looking for, right? Especially if rounding, it could change your data if you have weird numbers that aren't just like 0. So, but I want to make sure that you guys are aware that there is an operator and the fact that you can wrap it around multiple times like we just did. do I have any questions on the fact that we can do math in SQL or with the round operator? All right, moving forward. So we were able to grab everything with average, sum. We were able to use count. Now let's see. We're gonna go back to how we were able to grab red. This time we're gonna go ahead and grab makes of our cars. We can say select all from car where make is equal to Honda. And it does the exact same thing that we did with color, but this time it's only grabbing make. And there was only one item here that was of make Honda. But what if we don't have a type of data that is strictly just like Honda? What if we want to do something like, if this field has something like Honda, right? Or if it contains different words, right? Or if someone's name has John in it, right? Well, we can be a little bit specific like that too. We can say something like select all from driver. And when we go to the driver table, we see that we have a bunch of names, right? And if we're looking for something that is like Johnson, we're actually able to query that as well. We can say select all from driver where name is like Johnson. And what we have to do here is specify where in this string this might be, whether it's at the start, whether it's at the end, or whether it's in the middle of the string somewhere, right? And to do that, we use the percent sign, right? If we want to get a name where it ends with Johnson, we would say percent Johnson. I believe it's percent Johnson, or it's the other way around. So by doing this, it's going to say, hey, I want to grab all the, everything from the driver where it ends with Johnson. And we run this, we see that we get Michael Johnson. This query worked, right? Johnson is at the end of the string. We wanted to choose something that was like Johnson, where Johnson is the last part of the string that we are looking for. And we were able to successfully do that. We got the entire, field for Johnson. Yes, Tristan.
So if you were to look for something that's, say, somewhere in the middle, would you put a percent on the start and the end of it? So it signifies it's in the middle?
That is correct. That was the next part. But yes, Tristan, you hit the the nail right on the head. If we want to grab
I was
something
wondering the same thing. I was thinking.
Good stuff. It's okay. Good stuff. Yeah, if we want to grab something that we don't know if it's exactly in the beginning or the end, it could be anywhere within the string, we would add a percent sign to the front and the back. Right. So we were able to grab that for the names. Let's do that for the emails. We can say select all from driver where email like, and then I'm going to say percent sign. I'm looking for everything that belongs to example.com. And we see here that everything that ends with example.com within the email is returned to us. Right, so that takes care of that. And just like Tristan brought up, what if you want to find something that's somewhere within the string? Well, we can use the percent sign before and after. This time, I want to find anything that might have a J within the first name, right? Or anything within the name. So we can say select all from employees where, let's go to employees, All right, so I see employees here. Oh, this example is for the start, where first name, like, we're looking for J. We're gonna put the percent sign at the right side. That means we're saying anything that starts with a J. And we see here we get John and Jane, but not Robert, because John and Jane both start with a J. So this is the example of getting it from the start. And now back to Tristan's example. He mentioned about getting it somewhere from the string. We can use plates as an example. All right, we have a bunch of plates here. And for this scenario, we're looking for any plate that might have an X anywhere within the plate number. So we can say select all from plate where plate number, like, and we'll do percent X%. And we get 2 rows back, one with ID 2 and one with ID 9, being these two. Right? Well, what if you're looking for something that might have an X, but what if you don't know if it's capital letter or if it's a lowercase letter? Well, you are able to query it with case insensitive, I believe is what it's called. Sorry, English is hard. We can say select all from plate where plate number. And then instead of a like, we're going to say I like. Right? This would be I like. And then we do the exact same thing we did earlier. This time I'm going to do a lowercase x. And we see here that we get the exact same result we got when we use the capital X. This time we use a lowercase x, but it still returned to me everything within here for plate number that contains an X. With the I like, we essentially say, hey, I don't care if it's lowercase or capitalized, return it back to me. Do I have any questions about how we use the like or I like clause? Right on. Okay. Next, we'll be using the in operator, right? In operator allows us to pass in some form of a list, and we can use the contents within this list to see if anything matches, right? If we wanted to grab, let's go to cars, specific cars that share a specific color type, we could use the in operator. We would say select all from car where color is, and then we open and close parentheses, and within here we would add the different types of strings that we want to compare it with. We can say red, white, and blue. Right? And what this is going to do is going to check everything from car, and it's going to compare it to whatever is in this list of colors. And when we run it, we see here that we only got back responses from stuff that shares blue, red, and white within our table. Right? So we were able to do it with strings, but what about stuff like year? Well, we can do the exact same thing. We're going to change color, and we're going to add year. And then within our list, we will do 2017, 2020, and 2022. This time, it wasn't dependent on the color, it was by the year. And we see here that all the years on these responses share the years within our in operators parentheses 2017, 2020, and 2022. Do I have any questions about the in operator? I understand I am going pretty fast, right? A lot of these queries, honestly, Postgres SQL, or honestly SQL just in general, it's one of those perishable skills. So like everything that we do in our lifetime, especially like stuff like the army, if you don't train stuff, you are bound to forget it. It's one of those skills that you kind of have to do work and code frequently to ensure that you still got it, right? Don't be surprised if you add in your resume, you know, PostgreSQL or SQL as one of your languages, and you show up to interview, and they ask you, if I wanted to grab this from this, how would I do that? Right? It's happened to me before, and it sucks because like PostgreSQL, it's pretty straightforward, right? It's one of the more lighter topics within the curriculum, but because of that, we tend to not focus on it too much, or we, kind of ignore it, put it in the back burner while we focus on like Django and React, or like the main meat and potatoes of our program, and we don't use SQL too often, and then we get a question about it. All right, so do yourself a favor and ensure you guys stay up to speed on your SQL even after the cohort is complete. All right, so moving forward, we have the in operator. The next thing we're going to talk about is using, which I believe are called aliases, right? So sometimes we have tables or fields that just have such a long name, and what we can do is, or correction, let me rephrase what I said. Sometimes they have a name that maybe doesn't fit of how we were trying to get the response. Take, for example, the color, right? Color isn't going to tell me too much. What if I want to ensure that whenever I get this response, it says something like vehicle color? Well, the database has it as color, but I want my response to say vehicle color. The way that I would do that would be saying select color as vehicle color, right? So I give it what I want to call it and return to me. And I say from car. And we see here that it returns all the colors I have within my table, but the name of this column is called vehicle color now. Note that it does not change the actual name of your column in your database. It's just how it's labeled when the information is received and given to you, because that's the temporary alias that you established, right? So this does not change your actual database. It just formats how the data is presented to you. Any questions on how to use the as operator? All right. So next, let's try to start adding some more stuff in here. We can say select. We're gonna get the sum of my price. This is gonna be in regards to my services. All right, I'm gonna select the sum of my prices, and I'm going to give an alias as complete service cost from services. All right, if I wanted to get an idea of what my complete package would look like, I can get the sum of it, and I can even give an alias to format that data so I know what it is when it's presented to me. And we see here, we get the sum of our prices with our alias complete service cost. We can also do the as operator with multiple other field types, right? So up to this point, we've done select all, or we've done select and then just giving it one argument, but we can get multiple arguments. We can say select, we're gonna say name of service. All right, that's one of the columns here, comma, price, and then I'm gonna give an alias to this price. I'm gonna say as service cost from services. Right, so I was able to query two different columns. One of these columns, I gave an alias, and I want to grab this from services. And we see here that I have the name of service and the service cost with my alias here, service cost, taking the place of what originally was named just price. Any comments or questions in regards to the as operator or querying multiple columns? Yes, Owen.
If you wanted to rename the name of service column, would you just do say service comma service cost? Would that be applicable?
It should be name of service as service, comma, price as service cost. Is that what you're asking? From services. Is that your question, Owen? You're muted.
Yeah, that answered it. Thank you.
Awesome, no problem. Yeah, so we are able to use it on both sides. However, arguments you add in here, you can add aliases to every single one of them. So here is now, what if we only want to limit our responses to a certain amount, right? We've done select all from car, where we grabbed every field from car, and it gives us every field, but it's also giving us every single entry within our car table. We've added different parameters in here where we said like where name is equal to this, or where price or year is less than or greater than a specific number. But what if we actually want to add just a specific limit? We don't want to add a where clause. We just want to limit. Hey, I want to give me everything, every field from car, but only give me responses back. But we can use the limit operator or limit clause. We can say limit 3. And we see here that it's going to give me the first 3 that I have in my table. All right. Well, I was able to get a limit of 3, but now let's talk about ordering them. How do I want to order my response? Right, the data that I'm retrieving, what if I want it in a specific order? Well, we're going to use the car for this example. I want to grab all the cars and I want to order them by their model. So I can say select all from car, and I'm going to use the order by clause, order by model. Actually, let's do it without the model first. And we see it's right now being ordered by the ID, right? It's from 1 to 10. But now, if I say order by, and I change it to order it by the model, we see, I'm getting an issue.
You spelled order wrong.
Oh,
Order.
you're absolutely right. Thank you. We see here that our response differs from our initial query, where at first it was ordered by default by the ID in sequence. This time, we see the IDs are all fumbled. That means that my data here is in a different order, and it's ordering it by the model. Notice that the first item, right, was numbers. So whenever you use the order by, it's going to prioritize the numbers and then the strings. right? So what if I didn't want it to show me the numbers first, and I wanted to show me the strings, where I can say order by model, and then I can add another clause after that, which is going to be descending, or DESC for short. And when I run that, notice that this time the start of the my response is in strings, and then the numbers are at the very bottom. Yes, Gary, I can do it in the same order. Do I have any questions on the order by or the descending clause? Awesome. Moving forward. So we talked about order, order by. We can also do select all from card, order by ID. We saw originally the IDs were in order. So I can say this time I'm going to descend. Notice that it's backwards now from 10 to 1. But let's also give it a limit. I can limit 3. And I get 10, 9, 8. Select all from card, ordered by the ID, and descending order, limit 3. Next, we're going to talk about grouping. If I want to group my cars by a make, I would do something like this, where I would say select. I want to get the make. And then the next column I want a count of all. Well, a count of all of what? Well, I want to grab this from car. And then this count clause is going to be depending on the group by clause. Group by make. And when I run this, I see that I have my make and my count. My make shows me all the makes of my cars, and it's going to count how many of each make they have. If I don't have this group by, it won't know what to do with the count. Right, so we need the group by. The count is dependent on the make. That's because we added this clause right here where we're asking for make. Well, what are we counting? I see I have make here, but how do you want to count it? Right, and we use the group by to give it some help so it knows what we want to group. This won't work either, right? Because we don't have a count no more, and we don't know how many they're going to be grouped. So when grouping, you need to ensure that you have the group by make. Right? The count make is an aggregate function that counts the non-null values in the make column. Right? So the grouping requirement, group by clause, SQL doesn't know how to organize your make values, counting. As a result, it will throw an error because it cannot mix aggregated and non-aggregated columns in the select statement without grouping. Right? So it's important that we have the group by. Let's use some other columns. Let's say select year, count all from car, right? Let's look at my car. Oh, I am on my car one. From car, and I want to group by year. We see here we get the years, and then we have a count of how many times they appear. We can do the same thing. This time, we're going to add our descending clause. And I'm going to limit it to 3. Oh, what did I do wrong? Group by. Okay, I see group by year, order by year. It doesn't know how to do the descending. It needs the order by, and there we go. We can say select the year and the count of the year. Well, what are we counting? The groups of year. I want to order it by the year, descending, and only return to me 3. Earlier, when I tried to run this, it didn't know how to use descending because I didn't have the order by. By adding it, I let it know how I want to order the descending fields, and it gives me 20, 22, 21, 20. It ordered it by the year, and then it gives me the counts. I think if I change count, it might order it differently. Yep, it did. It ordered it differently for me. All right, so it needed that order by, so it knows how to format it for me. Do I have any questions on the count or the group by? I know this one might have been a little bit more confusing compared to everything we covered so far. No questions. Everyone got it. Good to go. You guys can repeat this again.
I think I understand group by more because that was another thing I learned before and it was hard for me to grasp, but looking over your examples was pretty helpful.
Oh, right on, Jacob. That's what I like to hear. All right. So we talked about group by, ordering. Next, we're going to use some form of like a conditional, and it's called the case clause, right? It's similar to the as clause, but let's say we want specific headers only if we meet certain requirements, right? A certain condition. We're going to use the service table for this one. I have my ID, the name of service, and price. I'm going to select, and I want to return the price, but I don't want it to just say price. I want to tell me whether it's low, medium, or high, depending on whatever the fields are in price, right? So to do that, I can use the case clause. It's almost like, I think it's like a switch, it's almost like switch in Python, right? Where we check if something meets a criteria, and if it does, we move forward with a certain line of code. It's something very similar to that. All right, so we can say select case, and after I say case, I can start my my query where I can say when price is less than 30. So if it's less than 30, then I want to return low. I'm gonna go ahead and press enter so I can move on to the next line. As long as you don't press or add a semicolon, it won't run your query. So if you want to split up your query so you can add multiple different calls, you can. So I press enter so I can run the next part of this query. So I'm gonna say, hey, when the price is less than 30, then I want the field to say low. When price is less than 50, then I want the field to say medium. Else, it should say high. Then I want to end as price range. from services. So what is it saying, right? Well, the case clause open a conditional statement, right, for my column price range, right? The column doesn't get created until it reaches this part here, price range, right? This case clause is referring to whatever price range should be, right? And then in price range, it's going to have my prices, but instead of having numbers, it's going to give me low, medium, and high. So after I set up this column here, I want to grab it from services and I can run this. And I see here, it creates my table range, but the actual prices in there are no longer prices. They're strings that are either low, low, or high, right? If I didn't do that, I would have done something like select price from services, and it would have returned this, right? Where it had my price with like the actual integer itself. If I wanted to change my price range column, I could have done as price range from services. And we see here, it looking close to what my case was, where the table column is called price range. But notice that the actual fields in here, the rows, are the actual numbers that are referring to price. Well, with the case, we changed the data that we were receiving within these rows. That data was changed here with the case clause, right? We said select case, and we added that condition statement where if price is less than 30, I want low. If it's less than 50, medium. If not, if it's none of those, give me high, right? The end as price range is me saying, hey, I'm done with my condition statement. Now I want to give an alias to price, and that alias is going to be price range. And then finally, I can tell it where I want to grab it from. And it gave me the price range low, low, high. So all this was just for one column. I can still add other columns, right? I can say NS price range, comma, name of service, run it, and it gives me two columns. I get range one and the name of service one, right? So everything from case to price range was all for the first column that I was trying to create. After that, I added my additional columns that I wanted to add. All right, so the case, once again, to reiterate, that part of the query creates a new column named price range based on the value in the price column. Right? Do I have any questions? This was probably the most confusing one of them all. All right, we're gonna go ahead and pause real quick, take a quick 10-minute break. All right, let's go ahead and jump back into it, guys. We are now moving into the joins. We covered everything about querying that you guys should know for the most part. There's multiple other things you guys could learn out there, different query parameters and operators you guys can use. These are the most common ones that you will see and that you will need pretty much for your day-to-day life working with SQL. If you are hungry for more knowledge, I recommend to look at documents and see what else is out there. At the end of today's class, we'll talk about some tools that you might be able to use to help you to get better at querying. But and move forward, the next thing we're going to cover is left joins, right joins, and full joins. So up to this point, we've only been querying from individual tables, but now it's time to kind of put these relationships to some use, right? So let's see. We have a couple of relationships here. We have car, and in car, we see that we have a column for driver, which currently holds the ID to our driver, right? We see driver 1, 2, 1, 3, 4, so on and so forth. And those are in reference to our driver table. And the first thing we're going to talk about is going to be the full join. And the reason for that is because full joins are going to be the most common ones that you'll probably use. They're the most used ones out in the industry, and probably the easiest one to understand. So let's talk about your full join. Let's go to TL draw. And I'll try my best to kind of draw it out for you guys so you can see a visual representation. Essentially, what we have is going to be two tables. Can I fill it in? I can't. And I'm not the best at TL draw, guys, so please bear with me. We have our car table, and we have our driver table. And as we saw here, our car table has a column for driver. And here we have driver. Let's kind of format it so I can give this to you guys later. Why is it not doing what I want it to do? This is a lot harder than it looks. Okay, let's just make this bigger. All right, so we have driver here, and this column has different numbers. We'll say 1, 2, and 3. And this driver column is a foreign key that is currently referencing to our driver table. The name of this is currently ID. Ideally, you probably want to make it driver ID because it can get very confusing once you start trying to grab IDs when you start querying stuff. So it's good to give it a unique name like driver ID that's supposed to reference directly to this table. And this table has the same thing as what car has. Right, it has the 1 and the 2 and the 3. And when we do a full join, what's going to happen is that we are going to grab car, and we're going to grab our driver, and we're going to want to link them to wherever driver, right? The column driver and car is equal to the column driver ID in driver. And a full join is exactly as what it sounds like. It's going to grab everything from both tables and bring them together at a specific location where they have some kind of similarity or relationship, right? That relationship is currently within the driver ID, right? So coming back here, the way that we do a full join will be just like this. We're going to say select, and I want to select everything from the car table. And the way that that is done is by calling the name of the table and then using the dot method to grab either a specific field in there, or you can use the asterisk to grab everything, right? We'll say select car dot all, and I'm gonna grab select driver dot all from car, and then I want to join car, so we'll say join driver. So I want to join driver into car. So we say select car all, driver all from car, join driver. Right? Still with me? And then where or how do I want to join them? Well, I want to join them on whatever car.driver, right? This column right here, the driver foreign key is equal to the driver.id, right? That is the similarity that they share, that relationship. So that's how I want to join them together. And then when I run this, we see here that we get both tables, right? On the left side, we have the car table. It has all the fields from ID all the way to that foreign key driver. On the right side, we have the driver table, every field from driver, right? And we're joining them here on driver and driver ID, right? Very similar to how this table looks like. Right? So now we talked about aliases before, and we can kind of do something very similar to that. Right? Here, we can say something like select, and then the alias I'm going to have for my car table is going to be C. I'll say C.all, comma, D.all. Right? So I want to select everything from C and D. C is the alias I'm using for my car table. D is the alias I'm using for my driver table. Where do I want to grab this from? I want to grab it from car. And this is where I actually establish my alias. After I call the table that I want to grab it from, I then add the alias right afterwards. So car space C. So when it runs this query, it's going to see this. It's going to check where it's grabbing it from. And it sees here, oh, okay, car has an alias of C. Therefore, you are referencing the car table at this part of your code. And then same thing for driver. We're going to do it just like we did before. Join driver space D, right? We gave the D alias. And then once again, we're going to tell it where we want to join this. It's going to be on. And because we established that alias, we can use it here as well. We can say C dot driver, right? Table car at column driver is equal to table D at column ID. And when we run this, we get the exact same thing that we got earlier, right? Two different ways of running it. One is the full name of it, but as you see here, we can add some aliases so we don't have to type out the entire name of our table. Do I have? Yes, Jacob.
Just to be clear on these two tables joining, so back to like when you were comparing car.driver to driver.id, so like the ID all the way to the left of that table, like that's just like the indexing, right? That's just like the one all the way to the left, next to make. That one is just like the index of each entry into the table, right? And then like the driver on the other side, that's the actual, like that's representing the ID, the actual ID number of the driver. Is that correct? I'm assuming that, like, I'm trying to find out like why, like, you know, like the ID all the way to the left is 1 through 10, and then the driver one is like 1, 2, 1, 3, 4, and then the other one matches that. Like, do you get what I mean? Trying to like differentiate between all those.
Okay, you're trying to figure out why the IDs don't match.
Yeah.
Sure. Well, the car and driver, what kind of relationship do they have?
It was 1 to many, right?
Yeah, right. One to many, many to one. that means that multiple cars, right, can have the same driver,
Okay.
right? But not, which call it not every which call it every person. How do I say this? The many and many relationship is what really establishes here. We see here that every person has multiple cars. Well, not everyone, but some of those
Yeah,
do.
some of them
Michael
do.
Johnson has a Toyota
Okay.
and he has a Honda, which is why this one, although we have their unique cars,
Mhm.
their driver is the same. Therefore, Michael
Okay.
Johnson shows up twice, right? That's why this
Okay.
isn't exactly how you would think it would be, whereas 1, 2, 3, so on and so forth.
Yeah, I got you. Okay, cool. All right, thank you. I appreciate that.
No problem. Yes, one.
For the aliasing, that's only working during the current iteration before you hit the semicolon and hit enter, right? That's not something that will apply from now on and that you can change later.
Correct. It's not going to change anything in your database. It's just when you're writing your query, it just makes it easier so you don't have to spell out the whole thing. Yes, Gary.
Could you just go over the last select C dot asterisk, like that line again?
Select C. Yeah.
Yep.
So just like we did the asterisk to get everything from something, we're doing that here. We want to grab everything from the car. So car.off. If we wanted to change that, we could, right? We can do something like select car dot make car dot model, and then I want to say driver dot name. Right, we can specify exactly what field we want to get from car join driver on car dot driver is equal to driver dot ID. And we see here that we now only get make model name because here we specified exactly what columns we wanted. On this query, we did not. We wanted to grab everything, right? So we said C.A, D.A. The C is the alias that we created, right? That alias is right here. Whenever we told it from where we want to grab the information and what we're trying to join, we gave it an alias. So when it runs this part, it's going to see, hey, what in the world is C? Well, once it gets to the rest of the query, it's going to say, oh, okay, I see. You want to grab it from car, and you gave it the alias of C, which is why we use C. The dot is kind of like we're using dot notation to grab stuff that belongs to this. They're essentially almost like objects, right? So whenever you try to grab things from an object in OOP, right, we use like the dot notation. It's kind of similar to that, right? So right here, we do select car dot make. We want to grab the make that belongs to the car table. We want to grab the model that belongs to the car table and the name that belongs to the driver table. Does that answer your question, Gary?
Yeah, I think you writing it out like that just connecting the dots for me. Thank you.
Okay, no problem. James.
Does the order when you do the join, you're doing each time you've done car join driver, would you be able to do driver dot or driver join car? Does that not make sense? And there's a reason for that?
It's how we join them. I don't think it's gonna work, but we can try it out. We could say from driver join car, and if it does, it's gonna look weird, I think. Oh, I guess it doesn't make a difference. It'll make a difference when we start doing left joins and right joins, but I guess for the full join, it doesn't make a difference. Thank you for that question. We learn something new
Okay,
every
yeah,
day.
just curious. Does that have to do with, you said it'll matter later because of like how it's cascading, like when you're building the tables, is that where that comes from, or is it something else?
It'll matter later with the left join and the right join, because what you're gonna see is that sometimes you don't have data on certain tables. And you'll see once we get to left and right join.
Okay,
what I
cool.
mean.
Yeah. Thanks.
Yeah, no problem. Any questions on the full join? All right, building off on the full join, we have the select C.all, D.all from car C, join driver D on wherever the IDs match. Well, we can also add some formatting here. We can say order by, and I want to order it. Actually, let's see what this gives us so I can have it here on it. All right, so we have this, right? If I want to order it in a certain manner, I can say order by, and I want to order this by the age of my drivers. So I can say order by driver.age. Once again, we're trying to access the field age that currently belongs to the driver table. So we have to call the table, and I already created an alias, so I don't need to type in driver. I can say d.age. Right, and we see here that it now changed, where before it was ordered by the IDs by default. Here it's no longer ordered by the IDs, but it's ordered by the age, right? From 28 being the youngest to 50 being the oldest. And even more so, I could add in descending order too. I can say 50 to 28, right? So it starts from the oldest to the youngest. And I should be able to do limit 3. And it only gives me the 3 from descending order. Right, so there is some formatting we can add there. Any questions about ordering our full joins at all? All right, we got 17 minutes left, so let's finish off the last one. Next is going to be our left joins and our right joins. Right, so for a left join, it sounds exactly as, or it is exactly as you hear it, right? We have select. We're going to grab everything from the car table. And then this time, we're only going to grab the name and the age from our driver. So we'll say d.name and d.age. I want to grab this from car, give it the alias of C. I want to left join, right? Left join the driver, give it the alias of D. On, once again, C.driver is equal to driver.id. Oh, my bad. I didn't give it the alias. There we go. So earlier it gave me an error because when I try to compare the IDs, I use driver instead of the alias that was given to it, which was D. So then I changed it and now it works. All right, so here we see we got everything from the car table, but this time we only have the name and the age from the driver table. We no longer have the ID there, right? We still have the driver ID foreign key that's currently within the car table because we said select all, but the driver table itself, I'm sorry, I think I misspoke, from the car table. So I'm getting confused with all these tables. We got everything from the car table, including its foreign key, right? But the driver table itself only returned to me the name and age because that's what I specified. I joined the table from the right to left. Now, what happens if I say right join? Notice that now I did a right join. I joined all the data from car into my driver table, right? Here's my driver table. Here's my car table. But there's an empty field here, right? I was able to grab everything from the driver table, but driver doesn't, there's a driver here, Linda Turner, that does not have a car. All right, she prefers public transportation. But because I did the left join, it's still grabbing this empty values for whatever Linda Turner has, but because she has nothing on there, it returns essentially an empty response for her. Because this is a right join, I'm gonna grab everything that's on the right, but the left, it's not gonna grab it if it doesn't have it. Right? Notice on the left join, Linda Turner is not present because it grabbed everything from the left table. These do have stuff, but Linda Turner doesn't show up because she didn't have a card. That's where that matters. Does that make sense, James? Of when one should come before the other? It's mainly on the left and the right joint. All right, so that is the difference between the left and the right and how they get the data. Right, it'll grab everything that has data for the one that you're specifying, whether it's left or whether it's right. But whatever you're trying to join into it, if it doesn't have data for it, it won't give it to you. It'll show you empty strings, or I believe it's null. I'm gonna give you guys the example I have here for the right join. For the right join, I had select c.make. I'm gonna get c.model, c.year. And I want to grab everything from driver. It's gonna be from car, C, join, or right join, driver D, on C.driver, where it equals D.id. All right, once again, we see that happening again here. We'll grab everything from our driver table, but Linda Turner did not have a car, so therefore it gave us that empty row for her that's coming from car. All right. Do I have any questions before we cover the many-to-many query? All right. For many-to-many, we're going to use the services and cars. So we don't need department. We don't need driver, employees, or plate. Let's go ahead and open up services. Let's open up car and car service. All right, so we have car and we have services. And we have a many-to-many connection between car and services, and that's being done here within this third table, which is car service. Right, we see here that there is a service here for service ID 1. Right, so someone has an oil change. Well, who has that oil change? Car ID 1. So this Toyota Camry has a service for oil change. Does it appear again? It does. It also has a service right here for a brake inspection. So this Toyota Camry has 2 different services, and 2 different services have a car that belongs to it. That's the many-to-many relationship that's here. Still with me, guys? Well, how do we grab that? Well, we're gonna do select. I'm gonna grab the make, the model, the year from my card. I also want to grab the name of service that this car has. I'm gonna give it an alias, which will be service. And I also want to grab the price of that service.
Your service for name of service was misspelled. I think you'll get an error for that.
Thank you very
Should
much.
be- yeah, no problem.
Right, so we are gonna grab all these fields from our car. I want to grab the name of service and the price from services. Right, so we're gonna grab all this information from both of these tables. Well, how do we do that? Well, I want to grab the car service, which is what's holding the relationship. And I'm gonna give it an alias of, actually, I won't give it an alias so we don't get confused. All right, I'm gonna grab the service table so I can join this together. I want to join services. Notice that we gave an alias here, which is S. So I'm gonna say S. Services S. I want to join services on car service dot service ID. So I want to join whatever service this is on the ID that it shares on my car service table. So this should equal to s.id. So whatever ID is currently in service that is also in service ID, that's the one I want to grab. And I want to join car. We have an alias of C here, so I'm gonna give it C. On car service dot car ID is equal to C dot ID. All right, so I also want to join the car wherever my car service ID right here, these, the blues, matches the IDs in my car. And we run that, and we're able to get the make, model, and year for all those cars. Also, the service and the price. I know this is very confusing. So let's try to dissect this a little bit before we call it, right? This line right here, all I'm doing is declaring what columns I want to grab from my service table and my car table, right? That's all that this is doing, right? I'm grabbing the make, model, and year from car. And I'm grabbing the name of service and the price here. Notice that the name of service, I'm giving an alias, right? I have to call the car service table because that's what's connecting these two together, right? So I call that third table that's supposed to be linking them together. And then I do the linking. Right? I say, I want to join my service table to whatever the service ID matches, right? So car service dot service ID, that's coming to this table here called call service. And it's looking for the service ID, right? I want to match that service ID that's within my car service table to the ID that services has, right? That's how I grab the services that currently have some form of relationship. It's not going to grab any other ID here that does not have a connection. It's only going to grab the ones that are currently within this connecting table. Once I take care of the services table, I move on to my car table. I say, hey, I want you to grab the items from car wherever the car ID in my car service table matches the ID of my cars. So these two lines here are grabbing the data for whatever has an existing relationship. Make sense?
It does, but it's gonna take me a minute to be able to write queries like that. Like, that's a lot.
Hey, full transparency, I have to do my own touch up too, because it's a while since I touched this, so I understand the struggle. Right. Now,
But your explanation was really well. It helped me.
I'm
really
trying my
understand
best,
that.
guys. English is my second language.
No,
English
no,
is
your
my second
explanation,
language.
your explanation was really good, but after like once I try to do it myself, I'm gonna be like, okay, let's see. But yeah, other than that, it was a good breakdown.
Fourth thing that you gotta take into consideration when doing this is the fields you're going to query, referencing the table that holds that relationship, which is the car service table, and then how your individual tables share that relationship with the car service table. And that's what we do here, right? We connect those to the car service. Those are the kind of like the 3 or 4 things you have to take into consideration when making a many-to-many query. Any questions? We got 4 minutes, guys. Any questions? All right. If I have no further questions, I'm gonna go ahead and stop the recording now.